Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my YouTube channel for Miss Lisa Blackburn for everything that I want to talk about science and math. And this is the class where we are going through notes. And this is Unit 6. We're going to be talking about the math of chemistry. All right. So on your notes, here's our essential question. How do I determine how much in a chemical reaction? So that's our EQ, our essential question for today. And then also, we have what are evidences of a chemical reaction, which was left from last time, which you're going to be finished in the lab. So I'm only going to talk 30 minutes or so, and then you're going to work on finishing up your lab today. Any questions about that? No. All right. So let me find my copy of the lab notes. They're pink, and I have misplaced them, but I can use these. Oh, there they are. I found them. Okay. So this is our question. How much? How much does a reaction make? How much stuff do you need to make a chemical reaction? Now, we can't just call it how much in chemistry, because we're nerds, and we have to have fancy science words so we can do nerd speak. So our fancy science word for all of this is a biggie. It's a doozy. It's stoichiometry. Doesn't that sound fancy? When your mama asked today, what did you learn in school today? You can say stoichiometry. It's stoichiometry. And that the official definition is mass and quantity relationships among reactants and products of a chemical reaction. I'm going to turn off the light so y'all can see it better. Here we go. Now, so what that is, fancy talk is, how do I get from a balanced chemical reaction to actually making chemicals? How do I get, using just the balanced equation and the periodic table, how can I actually make stuff in lab? Because that's what we want to do, right? We want things to change colors, possibly blow up. That's why we signed up for this class. Okay, so and I already told you that our reactions are like recipes. And what do you have to do for a reaction? What did we do in our last test? What did we do to them? Always have to do this to your chemical equations. It starts with a B. Balance. You got to balance them. So it's what the coefficients, those numbers you write in a balanced chemical equation, is what the coefficients or number of moles, that's the same thing, tells you. So for example, we're going to do the experiment in the lab, and we're going to use that for our experiment here. We'll do it when you get back from spring break. It'll give you something to look forward to coming back from spring break. We're going to make a kind of flavoring. Can you tell by your pictures what kind of flavoring? Look at the pictures on your notes. What is it? Banana. Right. We're going to make banana flavoring. Now, you can't taste it, but you can smell it. We don't taste stuff in the lab, especially stuff y'all make. All right. So here is our problem. Now, this problem that you're going to learn how to do, we know all the little parts of. We just got to know how to put it together. So here's our problem. Now when you read these problems, they're going to be word problems. And what makes word problems hard? The words. So what do we want to get rid of? The words. And make it math, because math is easy because your calculator will do it. You need to be sure to bring your calculator to class every day while we're doing this unit. So what we're going to do is we're going to do a skill you learned in English class. Annotating something, is that what y'all call it? What do y'all call it? Annotation, right. And that means we're just going to read through and look for those key words so we can get rid of all the unnecessary words. In math, you're always looking for the numbers. So you read, if you have, those three words, not important. 45 kilograms, that's a number, that's important. What is 45 kilograms? A mass, a volume, a length, a density. What's 45 kilograms? It's a mass. So I'm going to put a little M on top to remind me that that's a mass, okay? Of isoamyl alcohol, that's a chemical. We're in chemistry class. Those are probably important, okay? Isoamyl alcohol. And enough acetic acid, there's another chemical. I'm going to underline that one too because I'm in chemistry class. to react with it, how much banana flavoring. So what I don't know is how much banana flavoring. I look for those question words and I see what they go with. That lets me know what problem I'm doing. Can you make? Okay, now how do you do these problems? You know how to do each step. We're just going to put it together. Number one, you need to write the balanced chemical equation. And I've got it right here. And here is my alcohol. That's the acetic acid. That's the banana flavoring, and that's the water. Is this equation that I have balanced? I have 5 carbons plus 2 is 7. I've got 7. 12 hydrogens plus 4 is 16 hydrogens. I have 14 plus 2 is 16. I have 1 plus 2 is 3 oxygens. I have 2 plus 1 is 3 oxygens. So it's balanced. I'm going to put a little check mark next to it. I do that to let me know, oh yeah, I've already checked it. Don't do that again, because I'm ditzy. I'll get lost in the middle of it. All right, let's move up some. Are y'all okay with me moving to there? Yes? Austin, good with me rolling to there? Okay. So next, you write what you know, right. Whenever you do a math problem, you start off with writing what you know and what you don't know. So we're going to write what we know under the chemicals. I'm going to go through these steps. They're not going to make complete sense, but then we're going to do an example problem and they'll make more sense. Then we're going to stop and work on our lab. And tomorrow we'll do more example problems and it'll make even more sense. Okay, the next thing is sometimes you have to next use a conversion factor to make the units consistent. Consistent. Okay? So, for example, let's review how to do a conversion factor problem. Sean, what do I do first? Don't tell Donald, tell me. What do I do first? Write what I know, right. And what I know is 1 day. We're going to convert 1 day into seconds. So I write right here 1 day, what I know, just like Sean told me to. And I start drawing my railroad tracks. What do I write in the denominator?
What you know.
What I know, because I want to get rid of it. Who said that? Who was so brilliant and said that?
Me.
It was Donald?
Yes.
Very good. Okay, next, if I can, I write what I need to change it to, and it's seconds, but I don't know how many seconds are in a day. So I have to instead write what I do know. And I know that hours. And just like Dajay said, 24 hours is 1 day. I wrote day in the denominator so I could mark them out, because in math, you're allowed to mark out if you have the same thing in the numerator and denominator. Does that make sense? Okay, and the reason why I can do this mathematically is because 24 hours and 1 day are the same thing. And anything divided by itself is 1 in math. So this is equivalent to 1. And if I multiply anything by 1, I get that thing. And so I'm not changing its value by multiplying by 1. Okay, so now I want to get rid of hours. Anything I want to get rid of, I write in the denominator. What do I know about the relationship between hours and something smaller? Well, I know minutes. What's the relationship? 60 minutes and 1 hour. Now I want to get rid of minutes. And I know another one. What is it? 60 seconds is 1 minute. So hours mark out, minutes mark out, and I'm left with what I tried for seconds. Any number on top you multiply, any number on bottom you divide. So I do in my calculator. We're going to bring our calculators every day. 1 times 24 times 60 times 60, enter, divide by 1, divide by 1, divide by 1. You don't really have to do the ones because anything divided by 1 is itself. So somebody put it in your calculator and tell us the answer. Are you getting it, Kaylee? Yeah. What is it?
86,400.
Okay, so it equals 86,400 seconds, because in math and in science, a number without units is meaningless, and we box our answer there. Now, We don't have to do this on every one. Sometimes we can skip that step, but sometimes you have to do it. Now, usually how I do this problem is, as I say, whose birthday is the closest? And we figure out how many seconds it is to your birthday. But I know whose birthday is the closest. It's mine, because today is my birthday. So it is the day itself. So we did, it's not really that many seconds till my birthday, because today's my birthday.
Happy birthday.
Thank you, thank you. I've already got a cake from Honeymoon Bakery, my favorite bakery. I already got a bicycle for a gift. It's all turning out very nice.
You know, I love Bubba's birthday today, too.
Really? He was born on my birthday because he's younger than me. It's my brother-in-law's birthday today, too. And we were actually born on the same day. Like our moms were both having kids on the same day. My brother-in-law for my mother-in-law and me. Because my husband's older than me.
What time were you born?
He is a few hours older than me because I was born at like 6 in the morning, I think, and he was born like at 1 in the morning. So he's my elder by a few hours. My brother-in-law. Okay, next. Shh. I know it's very exciting talking about my birthday, but let's go on. The next step of the problem is we look up the molar masses. Where are we going to look those up? The periodic table. So we're going to look up the molar masses on the periodic table. Okay, and then you add them up for each chemical and write them under the chemicals in the reaction. The reaction is going to make a table that we're going to use for our math problem. It's going to organize it for us. If you're not converting with grams, write those ratios under the chemicals too, and this will make more sense tomorrow. Okay, then next you write the mole ratios from the balanced equation. Then we're going to draw a letter U. And you'll see why in just a minute. And then we're going to set up our conversion factors using train tracks. Because I don't like parentheses. I've seen kids get it wrong because their parentheses turned into sixes. And then they got the wrong thing. Train tracks. And then you put it in your calculator to do the math. That's the easy part, putting it in your calculator, getting the answer. It's going to make sense in just a second. I see a troubled look, but just a second, this will make sense. Has everybody got this written down?
Almost.
Almost. So we're also going to go play trivia tonight for my birthday at Mellow Mushroom. Have y'all, anybody ever done that?
I did that on my birthday.
I've never written it.
We have won a bunch of times,
Trivia gets me back to the front.
and it's fun to win.
How easily did you win? How easily did you guys win?
It's hard, but we've won a few times. We've got second and third also. See, my husband knows everything about like old 60s music. So if there's any question about that, we got it. My kids know everything about comic books, DC, anything like that, new culture, you know, young folk stuff. So we got that. And I got the science and math. And one of my sons knows all the history. So between us, we do really good unless there's a question on NASCAR or alcohol. We don't drink and we don't watch NASCAR. So as long as there's no NASCAR or alcohol, we're in good shape.
Those are the only ones my dad gets.
Then he needs to play on my team. See, occasionally I have a cousin who she would know those things. And one time we played, it was like, oh, we're going to win.
He either gets those or the rock music ones.
See, my husband knows all the rock music. Okay, can I scroll it now?
Almost. What are the rewards for winning?
You get gift cards. So like $25 for first place.
You guys get big, huh?
No, because it's way more expensive than $25 for us to all to eat at Mellow Mushroom. They're still making money on us, even when we win. But it's very fun when we win. The very first time we played, we lost, and we got a consolation prize. So we've almost always gotten something. Yes.
What do you get for money?
I did because you weren't here, but then you checked in with the machine, so it should have straightened it out. As long as you checked in with the machine, you're good. That straightens it out. I don't have to do it. Of course I marked you absent. You weren't there. All right. That would be bad if I'm marking you here when you're not. I'd be seeing things. All right, look. Okay, here's our problem, and now it's all going to make sense. Okay, here's our problem. You have 45 kilograms of isoamyl alcohol. That's just a kind of alcohol, and it's in kilograms. Now notice, y'all listen, I hear some talking. This is kilograms and that's grams, and when you do these problems, they need to be grams. So we're going to change it. Don't toss stuff. And we're going to do it because it's all metric with King Henry's daughter bakes delicious chocolate muffins. We are at kilo, which is here, and we're going to basic. So that's 1, 2, 3 frog hops. I augment zeros, 1, 2, 3 frog hops. It's 45,000 grams. And that's a mass. So I'm going to label it as a mass. Are we good so far? We underlined our chemical. We converted kilograms to grams. We labeled it as a mass. And enough acetic acid, I'm going to underline that because that's another chemical, it might be important, to react with it. How much banana flavoring, that's my question mark, can you make? And this is a gram to gram conversion problem. Now, what do I write first? Well, you know, but wait, I skipped a step. We looked at it before, but we always check to make sure our equation is balanced, but we already checked it, so let's put our check mark on there. Is the equation balanced? Yes. Now we write, you said it, what do we write?
What we know.
What we know, and it is underneath what we know, we check the chemical, and we write 45,000 grams underneath it. We also write what we
No.
don't know, right? What you do know and don't know. And what we don't know is banana flavoring is that one. We want to know how many grams of banana flavoring, write that underneath it. Are we good so far? We wrote what we know and what we don't know, and we balanced our equation. What's the next thing to do looking at your notes? What did I say to do next? No, we already balanced it. Next, we write our knowns and unknowns. What's the next thing? Write down the thingies, the molar mass, okay? So I want you to draw an M&M right here. It's why we have some M&Ms. And M&Ms are going to be our symbol for molar mass. So this is the M&M line, and we're going to write that down off the periodic table. We only need the molar masses of what we know and don't know. The rest don't matter. So first we're going to do the molar mass of this one, and this is how you do it. You list the chemicals. It's made out of carbon, hydrogen, and oxygen. Then I write how many I have. I have 5 carbons from that little 5, 12 hydrogens from that little 12, and I understood 1 oxygen. Are we good so far? Okay, next, we multiply them times their molar mass on the periodic table. What is the mass of carbon on the periodic table? 12. We're rounding to whole numbers. What's the mass of hydrogen?
Hydrogen is 1.
1. What's the mass of oxygen?
15.
So 15 rounds up to 16. Now we write those down. What is 12 times 5? 60. Y'all are so smart. What is 12 times 1? Y'all are so smart. What is 16 times 1? Y'all are so smart. Okay, now we add them up. And if we add them all up, it's 180 something. Where did I find it? No, it is. It's 88. 88. Okay, now that's my answer, and I write it here underneath the chemical, and the unit is grams per mole. 88 grams per mole for the molar mass line. Now I'm going to do this one. It's also carbon and hydrogen and oxygen. This time I have 7, 14, and 2. Carbon still weighs 12, hydrogen still weighs 1, and oxygen still weighs 16. I multiply them out. What is 7 times 12?
21.
No. It started with a 0, 12, 24, 36, 48, 60, 72, 84. Y'all know the song? 96, 108, 120, 121, 44. Did I say, what did I say? 84. I got too excited singing and forgot my answer. Okay, there it is. 84. 14 times 1 is 2 times 16. 32. Now I add them up, and this one is 130. 130. And I write it under here. 130 grams per mole. Does everybody understand how I did that? We practiced a little last time, but I didn't test you on it. And some of y'all came to ask me about it. I said, don't worry, you'll be tested on it next time. Well, now it's the time. Okay, next what we do is we look at the balanced equation and we write down the coefficients. What is understood to be right here? What number is in front of that understood to be? Well, 1. Remember on your test that there was nothing, you bubbled A for 1? So I'm going to put my 1 right there, and then 2 dots for a ratio. What's understood to be here? 1. A 1. This is a very important part, and I'll explain it to you in just a second why. Okay, what do I do next on my problem? Look back at the steps. What's next? Make a U, and I'm going to make it pretty. Now, the reason why we do the U is it shows us what order we do this in, and it also makes it look like your problem is smiling at you. Okay. Now, what do we do next? What does it say to do next? After the U. Set up your conversion factor. We're going to set it up by first writing what we know. So I'm going to change my pen to pink again. And I'm going to start here. What I know is 45,000 grams of alcohol. And I'm just putting big A for alcohol. Isoamyl alcohol. That's too much to write. It'll tire my hand out. Now, what do I write on the bottom? Grams of alcohol. Whatever is right here goes down here. Grams of alcohol. Now, so I'm starting right here. These are those grams. Here's the grams of alcohol. And look what's on the other side. What's on the other side of the slash? Moles. So that's what I write on the other side of my fraction bar. Now, what number goes with that grams? 88. What number do you think goes with moles? 1. It's an understood 1. Very good. Now, okay, I don't have my grams of banana flavoring yet. I can mark out grams of alcohol, but now what does need to go down here so I can mark it out? Moles. And those moles is this. These are moles. And right here are more moles. The number that goes with these moles is 1. The number that goes with those moles is also 1. This is moles of alcohol. This is moles of banana flavoring. Does that make sense? This is the hardest part. You have to go through this, and if you don't, you're going to mess up. Now, what I say is it's like the movie Elf. Have y'all seen Elf? If not, you might need to go watch it. I know it's Easter time, but you can watch a Christmas movie. Okay, not to spoil it, but Buddy is an elf, and he's left the North Pole, and he's come to New York City to find his biological father. And when he gets there, Santa tells him, don't eat the gum you see on the street. It's not free candy. He does anyway. And then he finds something really, really fun in New York City. Do you remember what it was? The revolving door. He keeps going through this revolving door. Ah! And he goes in a circle, and he's so excited to go in the revolving door. Do y'all remember that part of the movie? Yes. If not, you might need to watch it. Our mole ratio is our revolving door. If we do not do the mole ratio, we can't move from alcohol to banana flavoring. It's just like Buddy couldn't have gotten from inside the store to out on the streets in New York City. So when we play rock, paper, scissors, shoot, and you get stuck doing the problem as I'm walking you through it, and you're looking at me blankly, I go, ah, in a circle just like this, ah, then that means what you've forgotten is the mole ratio. Does everybody kind of gets a clue about this? I'll probably show you that part of the movie just as a refresher. Okay. All right, so now we can mark out our moles of alcohol, and we are now to bowls of banana flavoring. So now what needs to go down here? We want to mark it out, so what's going to go down here? Moles of banana flavoring. And that moles of banana flavoring is this one right here. Do you see that mole? That's it. See how we're going around the U? And the number that goes with that's an understood one. And what goes on top is what's on the other side of this fraction bar, 130 grams of banana flavoring. The moles of banana flavoring cross out, and I'm left with what I'm supposed to have, grams of banana flavoring. Are we good? Okay, now on your calculator, any number on top you multiply, any number on bottom you divide. So you'll go 45,000 times 1 times 1 times 130, enter, divided by 88, divide by 1, divide by 1, enter. Somebody do it on your calculator and tell me the answer. What is it? What's the answer? Everybody's got their calculator today? Kaylee, you've got it.
66,477.
66,400 and what? 77. And that's grams of banana flavoring, what we were supposed to have. Ta-da! We did it. So what do you think? I think y'all took it pretty good. Nobody cried. No one's got a rash. No one's run screaming out of the room. You're handling stoichiometry pretty good. All right, we're going to... You look like maybe you thought about it. You didn't look enthusiastic about the banana flavoring. Maybe once I show you the Buddy and the Elf, it will be better. Okay, let me see if that's as far as we're going to. All right, so this is where we're going to stop. Science is great.